Hello and good afternoon. I bid to Dr. Kamarul Ashar bin Kamaruddin and Professor Madya Technologies Dr. Saifulizan bin Jamian. My name is Steve Bernard Anna Petrus and my matrix card number is CD170032, and this is a video presentation of my research topic titled Simulation and Analysis of Vehicle Frontal Crash of Multi-Types Material Towards Road Divider. So this video presentation is in conjunction to the course BDA49002 Bachelor Degree Project 1, and I am supervised by Dr. Muhammad Norehan bin Ibrahim throughout the making of this research. So I'll start with the background of my research. So in automotive industry, structural analysis is one of the utmost importance in processes to develop a high quality vehicle, as vehicles are supposed to provide ample amount of protection to the driver and passengers in order to guarantee safety, especially on the road. So as one of the reasons for this structural analysis is important is to determine whether the vehicle structure itself is safe and ready to deploy, with the importance of the driver and the passenger should be safe driving the vehicle. So my research was targeted to take part in this similar agenda. However, the focus in this research is analyzing and simulating vehicle structures using different types of material which it will crash into a road divider. So this crash test or analysis provides very important or necessary information and opens up ways and possibilities to improve existing design of a particular vehicle structure. Before I go further into discussing this research, I'd like to mention that there are reasons to why I was conducting this project. So first and foremost, most modern vehicles as of now are commonly designed to move in higher speed, and while doing this, the vehicle itself has to be manufactured at a reduced production cost. So although it is important to do so, the quality of the vehicle structure must be optimal, as it should not abide the importance of road safety and passenger safety. Furthermore, road and or traffic accidents may happen in different types of situations, such as, first of all, collision between two or more vehicles. The second one, collision between a vehicle with an inanimate object. Inanimate object means objects that are not moving. And the third one, last but not least, collision between vehicle with animate objects such as human or moving items. So the problem statement that can arise from this is the dilemma into selecting the best or optimal design and materials that are suitable for the vehicle structure that meets the criteria of road and traffic safety. So the objective of my research are to design a model of frontal vehicle chassis or structure using SolidWorks. And the second objective is to conduct numerical analysis on frontal crash vehicle against road divider using ANSYS explicit finite method. And last but not least, I want to analyze the deformation, mode of failure, and crash worthiness on multi-types of material for the frontal vehicle chassis impacted against the road divider. So for the scope of this project, number one, this study is carried out only using one type of proposed model test vehicle, which is BMW X4M version 2020. The second one will be simulation on this research will be conducted multiple times with the materials selected for the vehicle structure is varied throughout each simulation. So the third scope will be the vehicles simulated will be assigned to only one speed range, which is 80 kilometers per hour, that possibly give the most impact during the collision test or simulation. The fourth one will be a road divider in this simulation will be assigned as a static subject and fully constrained to the ground. Last but not least, unlike the test vehicle, the road divider will remain using only one type of material and will not differ in terms of dimension and or specification throughout each multiple simulation. I believe that each and every research conducted has its own significance. So this research, however, has its own expected result and significance too. For instance, this research is made with expectation to identify and evaluate the behavior of the vehicle structure after collision with the road divider during this each simulation. So second one would be analysis made such as frontal vehicle structure deformation and the crash worthiness of each material selected for the vehicle structure are the essential foundations into selecting which material is optimal for the production of this vehicular structure. And last but not least, the usage of the word optimal here can be branched into which material provides first better protection to the passengers in the vehicle during the simulation, and secondly, to prove to why a certain material used for the vehicle structure has better performance and is more plausible in terms of option to compare with other materials to support the first statement. For this video presentation, I have included two of the most significant research journals documented by previous researchers. So these journals are important in order to comprehend the fundamentals of my own research topic. And the journals are titled Simulation of Vehicular Frontal Crash Test by T. Ambanti, K. Srikan and P. Viraju. This research journal is documented in 2012. And the second journal will be Determination of Frontal Offset Test Conditions based on crash data by S. Taki, W. Hollowell and O. Fesahai, which was documented on 1998. So these journals are important as the research led by T. Ambanti is relatively similar but objectively different from my own research, and the research led by S. Taki documented various types of crash test configuration with its own crash conditions. Now, I'd like to summarize the literature review of these two research journals that I've included in this video presentation. As for the first journal, titled Simulation of Vehicular Frontal Crash Test, I have summarized that a simulation was conducted via LS Dyna software, and it is about a frontal impact crash test of a vehicle model traveling into a rigid barrier at a speed of 56.3 km per hour. So, the vehicle type used in this research was Chevrolet C1500, which is a full-size pickup truck. Next, different types of material used within the compartments building up to the frontal part of the test model vehicle. And last but not least, the generated model simulation is done in 3 steps, which are pre-processing, solution, and post-processing. As for the second journal, which titled Determination of Frontal Offset Test Condition based on the crash data by S. Taki, I have summarized that simulation and analysis of this vehicle crash tests are conducted concerning specific crash conditions to obtain realistic results that nearly mimic real-life events in traffic accidents. So the crash configurations varied to types of vehicle crash tests and likely to vary in many in-depth parameters such as angle of contact between 2 or more subjects impeding to crash against each other. Next, the initial conditions and other explicit dynamics are present within the subjects that are impending to crash against each other are also factors that needed to be held accountable. So as you can see in the slides, the figure 2 shows type of crash configurations for each different test. The next section of this video presentation is about the methodologies used in this research. As you can see appearing on the screen right now is the flowchart of methods and approach that I've used throughout this research. So as you can see from the starting point, I've gathered sufficient information from research data on this research topic, and for the model geometry and the material properties that I'll be using for the simulation. So the next step, I'll be selecting and implementing suitable materials for the model geometry. And the next step will be constructing the model geometry of the vehicle structure and road divider using SolidWorks. And last but not least, for this section, model geometry, I'll be assembling the model geometry either using SolidWorks or I'll use ANSYS instead. So next step, which will be largely focusing on finite element method analysis. So as you can see on the screen right now, the first step I'll be using is selecting crash conditions of the simulation and list out whatever constraints or limitations that are supposed to be set before simulating the crash test for the model geometry. So the next step will be iterating any explicit dynamic analysis that's supposed to be counted or held accountable within the simulation. So the next step I'm using would be adding the data and model geometry by importing it into the ANSYS software. And for this section onward, I'll be using ANSYS, and for the previous section, which is the model geometry, it's all focused on using SolidWorks. So as we are moving on, so we're moving on into defining parameters and constraints for the simulation, which the parameters that I use are initial condition, type of analysis, mesh, solution, and lastly the boundary conditions for each model geometry. So the next step in this ANSYS software, I'll be defining the interchangeable parameter, which is the material, obviously. So the next step will be I'll start simulating the model geometry and start running the simulation with running the solver. So next, the result from the simulation will be in the form of the information visual in the post view. So for this visual info, I'll be recording the observation and gathered all the important data within the simulation. So the next step in this method will be selecting next material for the simulation, which it goes back to the previous step, which is defining the interchangeable parameter. So if the results that I'm getting is satisfactory, I'll be proceeding into the next method, next approach. Or if the results are not satisfactory, I'll be repeating the previous step, which is through defining parameters and constraints for the simulation. So as you can see, if the results that I'm getting is satisfactory, I'll be moving on into analyzing the data and providing the results and discussion for this research topic in my report, and I'll summarize it through concluding all the data, all the results that I'm getting, and that is all that is required for this research. So the geometry models used in this simulation and analysis of vehicle frontal crash of multi-types material towards rod divider, I'll be using for the test vehicle, I'll be using BMW X4M version 2020, and for the rod divider, I'll be using New Jersey type concrete rod divider. So why are these two models selected? So first of all, the reason would be the test vehicle, which is BMW X4M version 2020, was selected due to its accurate and actual blueprints or dimensions that are made available and ready for use in an online website. So the next reason would be the test vehicle selected in this simulation under the assumption that SUV type vehicles are uncommon type of vehicle used in other research that are similar to this topic. And last but not least, its collision partner, the New Jersey type concrete rod divider, is a common type of rod divider used in Parit Raja, and the inspiration into selecting this type of rod divider came from my own observation within the roads of Parit Raja. As appeared on the screen right now, these are the visual representation of both geometry models used for this research. So as you can see, these are the schematic diagrams for both the test vehicle and the concrete rod divider. The next slide appearing on the video right now will be the geometry model for test vehicle and the concrete rod divider designed via SolidWorks. Next, this is the visual representation of the assembled geometry models in ANSYS software. So as you can see on the slide, the test vehicle is placed behind the concrete rod divider. This arrangement is for fully frontal crash test, which is the type of crash configuration I am conducting for this research. So for the simulation of this research, the materials selected for the test vehicle are aluminium, steel and plastic. So note that plastic is also listed in the table. This material selection can be justified as front bumper of a vehicle commonly use special type of plastic such as ABS-PC. So appearing on the slide right now is the mechanical properties of each material selected for the test vehicle. So the next slide is about the mechanical properties of the concrete road divider. And as you can see appearing, the density of a concrete, the tensile strength, the Poisson ratio and the Young modulus all varied depending on the mixture of the concrete itself. As to conclude this video presentation, I'll be mentioning the procedures involved in simulation via ANSYS software. So first step will be selecting the materials for geometry models, and secondly, assembling the geometry models and the meshing in ANSYS, and last but not least, applying the parameters and explicit dynamics in that ANSYS software. After completing all this procedure, then the simulation can be solved by running the solver in the ANSYS. So I guess that is all for me. Thank you very much.